My name is Antti Siiskonen. I'm from Alma Media, specifically from Alma Media Partners. I'll explain it in a short while. I'm here to talk about the use of CDN in websites. We're using them ourselves, so we have some experience from that with some details to share that are not trivial or obvious for new CDN users or whatever. So, how many here are using CDN in their websites or infrastructure? A few. How many of you have actually set up them yourselves from a cloud provider or something? 1, 2, a couple of hands. Okay, so I'll start with the easiest part. That's me. I'm an old man already, looking at you. I'm actually from Lappeenranta, from the eastern Finland. I came to Tampere in 1996 and Tampere University of Technology for 10 years. So no 8-year limitations or 6-year limitations at the time. I started to work with Blenvare Oy, which I was doing embedded systems, mostly C, C++, some assembler here and there, whatever. Then Staselok Oy and Atostek Oy were basically the same company with the same ownership and a bit different focus. Atostek was doing customer projects and still is doing. Staselok was constructing a network device and I was doing the software for it. In 2008 I went to Alma Media, first to Alma Media Interactive, and then it transformed into Alma Media Partners. And as I told you, I'm an old man, I'm married, I have 3 children, I have no free time. So unlike you, I'm not practicing JavaScript frameworks on my free time and having fun. Alma Media Partners, so what's Alma Media Partners? It's a company, it's a subsidiary, like tytäryhtiö of Alma Media, and it's a part of Marketplaces division. The Marketplaces is like a virtual entity within Alma Media doing all kinds of marketplaces other than are listed here. We have some Eastern European other companies like LMC and like think of Monster.fi. They're like the Eastern European version of Monster, and they're doing that kind of things. Anyway, we're at Alma Media Partners are doing etuovi.com, autotalli.com, vuokraovi.com, and gofinland.fi, and they are like the consumer services that we're doing. And then we're doing ERP kind of systems for real estate managers and for construction people, building housing companies and whatever, for car salesmen and so forth. We have 84 people in total, and 26 of those are in IT. So we have lots of customer service people and sales people and whatnots, lots of people, and the IT is only, funnily enough, only a small part of our thing. So I asked for some numbers just to give you a sense of scale. 13.7 million euros of turnover, which is liikevaihto, and profit was 2.7 million euros. And only about 20% of the turnover comes from banner ads. So I noticed that there's this weird impression that even Finnish websites and companies running the websites can get a decent profit only from banner ads. But in my opinion, most of the money comes from the companies whose data we are displaying and serving and so forth. They pay us money to provide these websites for them. So that's why I'm here. I'm trying to tell you what we do. So if you're a competent IT worker doing trendy front-end development or whatever, please send an application if you're interested in our services. And we have 2 positions open at this very time, I think. One is for front-end development purposes and one is for more enterprisey Java kind of purposes. I'm not sure if you're really interested in that. Anyway. And if there are no positions open, you can always send an open application. We won't throw them away. They just get processed a bit more slowly, I think. So, on to the business end, why I'm here. What exactly is a CDN? CDN is a content distribution network. It's a distributed reverse HTTP proxy with cache. Most of you probably know the concept and the idea, but I'll just repeat them here anyway. A CDN acts as a mediator between an origin and a client. And the client would be a browser or some piece of software doing HTTP calls towards the origin. And the origin can be anything like a server, a load balancer, some kind of entity which has an IP address, and you can make requests to it. The CDN is referred to as a singular object, but usually it's a distributed object with many servers, many IP addresses, and it's a complex thing. Even the basic concept is very simple. Just to give you, again, a sense of scale, what does the distributed mean? We are using Amazon Web Services and their CDN implementation, which is CloudFront. It has 55 edges around the world, and each of the edges has tens or probably hundreds of servers, depending on the amount of traffic they receive, I presume. CloudFront does large-scale load balancing and distribution of traffic by DNS, so that if you have a server running in Finland and you make a request towards some example.com that points to a CDN, you'll probably get a different IP address or a set of IP addresses than from, let's say, from the UK or from the United States. So there might be hundreds or even thousands of IP addresses that receive requests for this example domain, and you don't even probably know where the request goes. So it's a bit difficult to, it doesn't have a clear form, the CDN object. So what's a reverse proxy? Well, a reverse proxy fetches content from the origin on the behalf of the client and passes it on to other clients as well. Usually the CDN is like the outer edge of the server or the service that you see. The clients, as in browsers, they usually don't see the actual origin directly at all. The edge, the CDN, caches the responses and serves them to the other clients requesting the same resource. So why would you want to use one? The main function and the big idea behind CDNs is to lower latencies and to provide a faster and better user experience. So all the JavaScript and CSS and various resources embedded in the pages just get delivered faster. Users do like that. There are other functions. One is to offload work from the origin. So the origin might have to run some heavy code when producing a web page or some response. So the CDN can remember the response so that the origin doesn't have to regenerate it always. There's also a non-obvious goal of creating a distributed entry point to the infrastructure so that as I described, the CDN may have thousands or hundreds of IP addresses. And if you think of DDoS attacks or some kind of network overload situations, the outer edge of your service is not a singular IP or a single server anywhere. It gets distributed widely, so it gets more difficult to just overflow or overwhelm your service with traffic. How long will a CDN cache my data? Well, there's the RFC 7234, which you can study, which basically says that there are two different kind of HTTP headers that direct the CDN, give instructions or hints of how long this object or response should remain in the cache. Also, the CDN will monitor how much traffic a single object, or how many requests a single object gets. And if it's a cold object that doesn't get any traffic, the CDN will probably remove the object or delete it from the memory. Well, for static content, obviously the time to live value should be practically indefinite, which is like year or 10 years or something. And also static objects that you release when you build your website and deliver it to the origin. You should always version your objects, give the file name some hash or version number or something, so that when you upgrade your software, the stuff gets upgraded and the changes are visible via the CDN as well. The other option is to use deliberately smaller TTL values so that the stuff expires from the cache quicker. But this is a bit tricky one because you can't predict very accurately when the data gets refreshed. Well, for dynamic content, as I told you, there are the on-demand pages that are generated programmatically every time they're requested. There are manual or scheduled triggers, like some cron entries or whatever, to generate some banner ads or whatever. These are kind of dynamic content that is basically the same cache key gives you different value based on the time when it's generated. The TTL should match the desired update interval, that's obvious. Also pass-through traffic that may not be cached at all, that might benefit for some reasons from using a CDN as well. I have more data on this later. How easy is it to deploy a CDN? Well, these are the basic steps with Amazon. We're using Amazon, so I don't know how easy or hard it would be with Google or some other provider, but I assume the basic steps are pretty much the same. You create an account, you need a credit card to deal with the billing. You use the web interface to create a distribution object, which has all the properties and the CDN configuration in it. You make some DNS changes so that your traffic doesn't go directly to the origin anymore, it runs through the CDN, and that's pretty much it. And Amazon deploys new CDN distributions and the configuration changes usually within 15 to 20 minutes. So they get propagated everywhere around the world. So here's a piece of data when we deployed CDN for etuovi.com. So this is the very moment, right here, when we in the morning just redirected all the traffic going through the CDN. And this is for favicon file, which is a static file. So this is like a trivial case where the CDN gets populated with the static file and the latency goes down to the lowest possible level. What is not trivial is the next slide, where we do the same for the front page. So this is dynamic content that is always regenerated upon request. And you can see the same 100 millisecond drop in the latency when run through the CDN. So this was not expected. We didn't know why this happened. We started to think about it. And the obvious answer is that Amazon buys dedicated network capacity from the origins, from their servers to the CDN edges. So even the traffic that must run to the origin through the CDN gets the same speed benefit and the latency benefit, which is kind of nice because it's easy to set up and it's cheap. And you don't have to fix your application, you get the speedier responses. So I wanted to talk about the effective use of a CDN, and I could basically talk about this slide only for the 25 minutes, but I had to give you the basics first. So you have to design your cache keys carefully. The obvious cache key is like the path and possibly query string of an object or a request, but at least the CloudFront does allow for using also HTTP headers and possibly cookies as part of the cache key. So in cookies you might have like a session ID or something, and I don't know, you could use possibly some HTTP header as well for some specific purpose, but you can craft a specific use case and figure out how long this kind of object should be cached and so forth. And to this work effectively, you have to partition your resources. You have to think about, I have these static files, I have these images, I have these dynamic contents, this has to be refreshed, this has to be passed through. You have to classify all the resources to be able to set up best possible caching strategies for them. It's not very difficult, but it is something that wasn't obvious for me before. So only when we deployed our CDN and looked at the data, what the CDN was telling us, which resources were being cached and what were the cache hit rates and so forth. After that, we could do fine-tuning and figure out what are the best possible setup for each resource. The usual cycle of design, deploy, measure, repeat, as long as you have to. You can't make it perfect, but you can certainly improve it over time. And CDN is very nice. It caches the responses, but it doesn't offload all the work. So if you have multiple parallel CDN nodes and you get multiple requests through each node, you have to do the same generation work for each node of the CDN. So we had this specific use case where we wanted to scale images. We thought it was a good idea to generate dynamically upon request a certain size of an image. And it turned out that the actual backend behind the CDN had to do the same scaling work so many times. We basically had to run much more servers in the backend. So we could only scale it once, store it to some place, and let the CDN pick it up from the storage. That turned out to be faster. Some pitfalls. The first is a quote that has been running around the internet for a long time. You will end up in a situation where you have something in your cache that shouldn't be there. It's something that you want to update, you want to have some other content with the same cache key, and it's difficult to get out. So CloudFront provides an invalidate function that you can give a list of paths or quarter strings or whatever, and it can invalidate from the cache everything. But the same stuff, of course, goes to the browser, so you can flush the browser's cache. There's no way to give instructions to the browser to forget something. Also, limiting access to the CDN can be difficult. Nowadays, CloudFront offers IP-based restrictions and geo restrictions and so forth, but the basic idea is to deliver the content, not prevent delivering the content. So there are limited features for the access. Basically, if you have test environments or, I don't know, QA environments and you don't want anyone else to access those than your own people, that can be tedious. Also, there are recommendations for domain sharding, which means that a browser can only open certain amount of parallel TCP connections to a single server. But I think this is a bit old information. I'm not very convinced that people should do domain sharding anymore. I think a proper CDN will probably do the thing, and also the browsers have been updated. They work better than before. So I wouldn't do that anymore. Also, for example, etuovi.com loads a lot of advertising and whatever from a zillion different domains. So you get the sharding even if you don't do it yourself. One last thing, HTTP 2.0, which is, I guess the standard is now complete, but implementations are still coming. It will change a lot of things, mainly because the server side can push related resources to the clients without the clients explicitly requesting them. So the server can be configured to follow referrer headers or whatever, and it can actually learn that when the browser requests this page, usually it needs this CSS and this JavaScript next. So it starts pushing these things already before the client requests them. So it's easy to see why this CDN function will probably be a bit different later on. So keep an eye on it. I don't know when the implementations start popping up, but I don't think it will take long. All right. That's it. Thank you.
Now, any difficult questions?
Sure.
Same guy here.
I'm not paid to do this, honestly. Is CDN, do you have to take it into account from day one when designing the system, or can you just, spray it on top if you get performance problems and make everything better?
That's an excellent question. In my opinion, you don't have to deploy the CDN at the day one, but you should consider the partitioning of your resources from the day one, so that you have in different folders, let's say, or under different paths, the different kind of objects that you want to cache differently if you want to cache them later on. So that will help. But popping the CDN on like in front of such a service that has been properly designed, considering these things, it's easy. Like we did with Etuovi, it was easy. No changes to the application at all.
Any other questions?
Thanks for the good presentation. I was wondering, when you advise to use, for example, the file names so that they have hashes or version numbers, is there any reason why not to use e-tag cache headers?
It's a bit different. I'm not sure if browsers actually use it every time, or if the CDN implementations provide the e-tag always. Also, the e-tag, it's a tough question, and I don't have a simple answer for that. With all the instructions that I've seen and when I've been studying this subject, there's the e-tag is mainly used between the CDN and the origin, but not so much between the CDN and the browser. But the basic function of e-tag obviously is to check out if the content has changed or not. So I don't know. Maybe it works, maybe it doesn't.
Any more?
So, have you only been using the Amazon CDNs, or did you consider some other alternatives? How did you end up going that route?
That's a good question. We didn't study broadly each and every provider. We basically started to transition from a traditional data center towards Amazon some 3 or 4 years ago, and we've been moving every consumer service has been migrated over to Amazon. So we get nice volume discounts and so forth, and it was obvious option. And also, as I told you, the CDN providers usually, if they have an origin on themselves, they purchase this custom bandwidth between the origins and edges. So we wouldn't probably get the benefit if we were using like Google's backend servers and Amazon CDN or vice versa. So it wasn't pre-planned, but I'm quite happy with the current state.
Right, and it also seems that most of the CDN providers are very kind of enterprises, so Amazon is a bit different in a way that you can kind of just pay for what you use rather than kind of backroom deals with the provider.
Well, I know that Amazon has like free tier or something. You can certain amount of traffic you can transmit through the CloudFront without any costs, or you can try it out very easily. They know how to sell this stuff. Probably Google has something similar. I don't know. I haven't studied the field over there. My experiences are based on CloudFront solely. So some other providers might have features or some use cases or whatever being better on some fields or worse on some fields than CloudFront. So take my word only for CloudFront. Do your own research and figure out if you're using other vendors.
Right. So yeah, not meaning to hijack your talk, but if you're doing more like hobby projects, one option is Cloudflare, I think, which is free for most like personal stuff, with which you can get both HTTP2 and a CDN for free. So
If that's what you choose, good luck. I'm sure they do a good job. I have nothing bad to say about Google or anything else. It's just we took this road and that's where we are now.
More questions? All right, thanks Antti.
Thank you.